Hello students, on the chapter Inverse Trigonometric Functions, we are going to study what is 1 and onto function, what is inverse of a function, then inverse of trigonometric function, their notation and their meaning, principal value branch of inverse trigonometric function, properties and identities containing inverse trigonometric functions. Before starting the chapter inverse trigonometric function, we should have a rough idea of the topic. What is 1 function? A function f from set x to set y is said to be 1 if every element of set x is associated with one and only one element of set y. It means, suppose this is set x, this is set y. Now if you look at this, element A is associated with element 1 of set y, then B is associated with 2, C with 3, and so all elements of set x are associated with element of set y, and only one element is associated with one element. That means one element is associated with one element. This is called as 1 function. If a function is not 1 we call it as many to one function or many one function, because A is associated with 1, B is associated with 1 also, C is associated with 4. So A and B have a common image. So this function is many one function. Because a function is said to be invertible if it is 1, so function to be invertible should be 1 and onto also. Now what is onto function? A function f(x) to y is said to be onto if every element of set y is the image of at least one element of set x. That means there is no element in set y which is not associated with element of set x. Here in this case 4 is not associated with any element in set x, so it is not onto function. Similarly in this case 2 and 3 have no pre-images or the element associated with the element in set x, so it is not onto function. Now this function is onto because 1 is associated with A and B, 2 is associated with C. There is no extra element in set y. That means every element of set y is image of at least one of the element of set x, so this is onto. But in this case this is not onto because 3 and 4 are not associated with any element in set x. So function is invertible only if it is 1 and onto both. That means one element of set x must have an image on set y with one element only. If this is the case, this is set x, this is set y, A is associated with 1, B is associated with 2, C is associated with 3. So this function is 1 and onto both. So this function can be invertible. Now what is meaning of inverse of a function? Suppose f is a function from set x to set y. Now it is invertible only if it is 1 and onto both, or we can call it as bijective function. And the inverse function is represented as f inverse, this symbol is for inverse, from y to x. That means this is domain and this is range if it is onto or bijective. So if we flip x and y, we get the inverse. That means if in simple terms, if y is equal to x plus 3, then x is equal to y minus 3 is called its inverse. The remaining thing you will discuss in detail in chapter relation and function. Now since trigonometric functions are many one functions over their domains, so we have to restrict their domains to a certain limit so that it will become 1 and onto function, so that we can find their inverse. That restricted domain is called as principal value branch or other branches. Now what is the meaning of inverse of trigonometric functions? Suppose there is an angle pi by 6. Now sine pi by 6 is half. That means the sine value of angle pi by 6 is 1 by 2. Now if we reverse this situation, that means if value of sine function is given which is half, then you have to find the angle x. Then the angle x is called as inverse of sine function. That means if sine x equal to 1 by 2, then for which angle the value is half? The answer is pi by 6. So we write it as sine inverse half is equal to pi by 6. So this is the notation for inverse sine function, and sine inverse x basically denotes is the angle for which value of sine function is x. Similarly for other trigonometric functions also. For example, cos inverse 1 by root 2. What does it mean? The angle for which value of cos function is 1 by root 2 is pi by 4. So cos inverse 1 by root 2 is the angle which is pi by 4. Now, as we already discussed, a function is invertible only if it is 1 1 and 1 2. Or you can say we can check whether it is a horizontal line test will pass or not. What is horizontal line test? If we draw a horizontal line, if the horizontal line intersects the graph at only one point, then the function is said to be invertible, or 1 1 basically. So here we see that the horizontal line intersects the sine graph at multiple points. So the sine function is not invertible in its respective domain. So we have to restrict its domain to a certain extent so that it becomes invertible, and that restricted domain is called as principal value branch. So here it is minus pi by 2 to pi by 2. So if angle x lies between in this interval, then we say that the sine function is invertible. On the basis of this, we have a table in which we mention the function, domain and range. Range is called principal value branch. Like in case of sine inverse x, domain is minus 1 to 1 and its principal value branch is minus pi by 2 to pi by 2. So sine inverse x lies between this interval. Similarly for cos inverse x, tan inverse x, cosec inverse x, sec inverse x and cot inverse x. So these are all principal value branches of these inverse trigonometric functions. Now one should remember that sine inverse x is not equal to sin x raised to power minus 1. That means don't be confused that sin x raised to power minus 1 is sin inverse x. That is a different thing. So sin x raised to power minus 1 is basically 1 by sin x or cosec x. And similarly this for other trigonometric functions also. And in problems involving inverse trigonometric functions, if no branch of inverse trigonometric function is mentioned, it is by default principal value branch. So while solving the problem, you should keep this in mind. Now there are some properties of inverse trigonometric functions. First is sine of sine inverse x is x if x belongs to minus 1 to minus 1. So sine of sine inverse x, this is known as composition, is x if x belongs to minus 1 to 1, and similarly reverse of this is sine inverse of sine x is x if x belongs to this interval. And this is true for all other trigonometric functions according to their respective domains. And these are the some properties. While solving the problem, you should keep these things in your mind. Sine inverse of minus x is minus sine inverse x. Then tan inverse of minus x is minus tan inverse x. Cosec inverse minus x is minus cosec inverse x. So in case of sine inverse minus x, tan inverse, cosec inverse, minus x we take minus sign outside it. But in case of cos inverse, sec inverse and cot inverse, we take it as pi minus this. Pi cos inverse minus x is pi minus cos inverse x. Similarly sec inverse minus x is pi minus sec inverse x, and cot inverse minus x is pi minus cot inverse x. So these things should be keep in mind while solving the problems. Suppose there is a question, evaluate cos inverse minus root 3 by 2. So what we have to do, first change this into pi minus cos inverse root 3 by 2. Now cos, the value of cos is root 3 by 2 at the angle pi by 6. So answer is pi minus pi by 6, which is 5 pi by 6. In this way you can solve the questions based on these properties. Similarly some properties are also there. Sin inverse 1 by x is cosec inverse x. These all properties are derived from the trigonometric functions. Cos inverse 1 by x is sec inverse x. Tan inverse 1 by x is cot inverse x with their conditions imposed. Then sin inverse x plus cos inverse x is pi by 2. Tan inverse x plus cot inverse x is also pi by 2. And cosec inverse x plus sec inverse x is pi by 2. So these identities should be remembered while solving the problems based on this topic. Now these are the formulas which are derived from trigonometric functions. As you studied in class 11, tan x plus y is tan x plus tan y upon 1 minus tan x tan y. So same formula is in the inverse is tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. And this formula is derived from the formula mentioned here. Similarly, tan inverse x minus tan inverse y is tan inverse x minus y upon 1 plus xy, where condition is that xy should be greater than minus 1. And these three more formulas are there which are derived from trigonometric functions. Like as we studied, sin 2a is 2 tan a upon 1 plus tan square a. So the above identity is derived from this formula. Similarly, cos 2a is 1 minus tan square a upon 1 plus tan square a. We derived the formula from second formula from this identity, and tan 2a is 2 tan a upon 1 minus tan square a. So these three inverse trigonometric properties are derived from these three trigonometric formulas. Okay.